a good amount of attendees, so we're going to kick things off. So firstly, thanks for joining today. It's great. We have a small audience here, so please feel free to ask questions as we go along. Kick things off. So yeah, thanks for joining. So today we're going to cover sort of beginner to advanced content, both for people who are thinking of using Teleport and also people who are running Teleport at scale. Please leave questions in the Q&A box. I have it open here. I'll be keeping an eye open. So, if you have a question pop up, feel free to ask them as the webinar starts. And you can also email us any questions. I send it to me first, but Stephen's email is also here. He's available to answer any questions on his demo. And we have our social channels. We'll also be recording this webinar and be putting on our YouTube channel afterwards. And lastly, if you have any questions, probably one of the best places to get feedback and answers is to just join our community Slack channel. It's goteleport.com/Slack. And we have about 600 people, including the majority of the Teleport team. We have people asking any questions from initial setup to sort of advanced configuration options. And we're more than happy to help out our community users and our enterprise users. So what is Teleport? Teleport is an access plane for accessing your infrastructure. We started off with just providing support for servers, and it's a real upgrade from moving from public-private keys to short-lived certificates. So one of the key benefits of Teleport is the ability to provide access to your infrastructure, but without having to worry about onboarding and offboarding public-private keys. And after about 3 years of providing server access, we added initial Kubernetes cluster access. This does the same thing for Kubernetes access by providing short-lived kube configs instead of having to send people kube configs that last for a long period of time. So, if someone's machine was compromised, there's no ability for that credentials to be able to access the cluster without people having to go through an SSO flow again. And last year, we added applications, and these are primarily internal applications. I can give a little demo later. And everything is sort of audited and recorded and provide behind the secure backend of Teleport. And this year, we've added database support. Same thing again, so short-lived credentials for humans accessing databases so you can know what your team is doing and what tables they're accessing and what commands are they running. So Teleport, how does it work? This is an example from our database slide, but the same concepts work for all of our other products. So we have end users who are connecting using their command line tools. This goes through to the Teleport service, which is a combination of our public proxy and a more secure hardened auth service. This would talk to your SSO provider, and this deals with all of your certificates. And in the case of our database service, this has a reverse tunnel, which provides the credentials to these databases. And so for an end user, what it looks like is they will do a TSH login, get their credentials for whichever database they want. Then they can just go about their day-to-day job just using pSQL or a GUI. And it's the same for Kubernetes. You can just use kubectl or SSH. You can use our command line TSH SSH. But this is our TLS and tokens edition. So we have tokens and certificates sort of all around Teleport. And one of the reasons for this webinar is we see lots of people sort of get confused because we have a range of options that, depending upon your setup, you might want to go with one because it's more secure than other. And our TLS endpoint, I'll cover in the end. We've made some improvements. This is just fixing the secure endpoint that your end clients will connect to. So why this topic? Why tokens via API keys? And I think one thing that's sort of a bit unique for Teleport is the way in which we generate tokens. We sort of try and create them as secure as possible. So we focus a lot on using dynamic tokens than, let's say, a static API key. And I'll show you an example of what these tokens mean. So many tokens in the world of Teleport they get created, and which shows diagram. And the token is only used for the initial joining of the cluster. This is both for Node, database, and Kubernetes. Once they've made that initial connection, it's all a mutual TLS connection. And we have other tools too. So once this connection's happened, that token is no longer needed. So you can make a very short-lived token. Then you can use our command line tools such as tcudl auth rotate, which will completely rotate the teleport internal certificate authority in case there's a probability issue or something has been compromised. Talking of systems being compromised, we have this attack tree available, and there's a few possible ways in which Teleport could be potentially compromised. One is stealing or brute forcing a node join token. And this is why we would suggest not using static tokens. So if a static token was leaked on GitHub, for example, someone could create a malicious node that looks exactly like one of your production nodes. This could sort of have escalation to other parts of the system. And more importantly, if you're setting Teleport in a high availability setup, you might have a proxy token, and you definitely don't want a proxy service to be compromised, because then it's sort of game over. So these are some of the concerns that you might want to think about as far as token management and token hygiene. So join tokens, we have a range that are available. Starting at the top, if you're setting Teleport in a high availability mode, you'll want to have tokens for adding new proxies or adding new auth servers. These can be both static and dynamic. The same with inviting users. You may want to just offload this to a SSO provider, but if you do have a dedicated user for backup, you will also have an invite token, and this is a dynamic. And then we have our services. So if you're adding a new node or Kubernetes or database, this can also be both static and dynamic. And then lastly, we have a trusted cluster. This is a feature of Teleport in which you can connect multiple clusters together to provide secure access to ones that are possibly behind the NAT or in secure environments. So I think we had a question. What is the plan going forward to handle dynamic Kubernetes environments in a GodOps way where short-lived tokens don't work? Yeah, we're going to answer this later on. So we'll come back to that one. But everyone else, feel free to ask any questions. So static tokens, this is an example of a terrible example of a static token. It's, we have 4 tokens here, and the proxy token is just 5 X's. So obviously this is, a token that will be very easily brute forced. So we'd recommend, firstly, if you're going to use static tokens, create very long tokens and make sure that they're sufficiently random. But this is another example in which, you can create all of these other services. They could have the same static token. So this is in the auth service. If you would have your node, you would then just hard code that static token to gain access. And then taking this up a notch, we have dynamic tokens. And so I'm just going to walk through. So the command is tcudl tokens add type node. And so we have the role available. We have the token, which is quite long and random. Next up, we have this CA pin. And the CA pin is a sort of an important feature if you're using, let's say, the IP address. So we can assume that in some environments, in a zero trust environment, that someone could spoof the 192 IP address. And so this is a hashed version of the auth CA. And so you can use this to make sure that your node is joining the right Teleport certificate authority. And then lastly, we have the auth server IP and port. In this setup, this is an internal network in which everything doesn't go over the public internet. And so it's over 3025. You might, if you're using our hosted version, this would go over 443, and this auth server IP would be the fully qualified domain name of your cluster. And then another example, we'd also recommend not adding tokens themselves, but instead using a file. All of the services support using file examples. So, you can use the same tcuddle tokens add, but grep for the token and save it out to a file. Distribute this file among your servers and have a central place. I'm going to show you how we do this with our AWS Terraform example. And then when you load it, you can, we're loading this in line, but it's the same thing if you're using our YAML, you just add it in the token file. Then lastly, we also have the Teleport certificate authority. And the certificate authority databases or OpenSSH. Our OpenSSH support requires you to do a lot more work. And this is kind of why we recommend using Teleport, because we do things such as automatically rotating the Teleport CA, but you can manage this all yourselves if you want to. For databases, often you'll need to export a range of certificates to be able to connect to those databases, but it's the same thing. You are using either auth sign or auth export to get credentials from the Teleport CA. And as I mentioned earlier, we have sort of examples of publishing tokens to a sort of central secret manager. For our Terraform HA example, which is available in our examples on GitHub, the Teleport auth publishes a token to secrets manager, and then these tokens obtain them using a defined role. The files are a little bit all over the place, but I kind of give you a sort of an example. So in the node themselves, we have this SSM get token, and we have an identity role, which basically you can see that we get the parameter, we decrypt it, and then we save this to the token file. And so when all of these nodes join, no tokens are shared between everything is sort of encrypted. And taking our Terraform one step further, we recently released an official Terraform provider. This Terraform provider lets you have more control over sort of some fundamental basics of Teleport, and Stephen's going to walk us through this. But we have this Teleport provision token, which provides all of the capabilities of what you want to add. And so you can add this as part of creation. And another thing, I think Stephen might touch on this, but when you're creating these tokens, you also want to create a role and a user for providing these tokens. So you also have an audit log and you see what's happening. And so this Terraform has the ability to list like all CRUD for all of these resources. And we've exported an example here, which we'll be able to use for a Terraform provider. And then lastly, we've done a lot of work in Teleport 6 around our API. And Stephen's going to do a deep dive into how you can use Teleport with our API. So it's on to the demo. I'm going to stop sharing and pass it over to Stephen.
Thanks, Ben. Yep. So this is what I got, the enterprise tenant, which is on our Teleport Pro, our hosted service, as Ben mentioned. In this example, you can see I have a app, database, and web server available. In this case, I want to expose a Jenkins service that's available. Now, you'll notice that none of these are labeled as Jenkins, so I haven't yet added that service into here. I want to add the SSH as well as the web interface, and that the web application would go here. It's not available yet. Now, in terms of how I'm going to add that, I'm going to use a combination of the Terraform provider as well as our API call. While the Terraform provider does also use the API, and essentially, as Ben was stepping through, you basically configure specific roles, and then you can issue identities or identity credentials so that the Terraform provider or your API can authenticate and then retrieve or post its specific information. Now, all of this information in terms of how to getting started is in our documentation. This is a great guide to get started on the API, which walks you through, like, you need a Go environment of 116 plus, what kind of users you need for using it, creating a Go project, and then we even have very straightforward sample code. This is a case of just pinging it. I'll show an example of mine, how I get the tokens, And then we also have our Terraform provider information, which again is a very straightforward way to use Terraform if whether or not you're familiar with Terraform. You could also use this in combination if you're going to build up like a node and then send in a token or configure a role for a specific node. So it's very straightforward there. Now, in terms of looking at how this was configured, let's take a look first at the Terraform. So in this case, we wanted to expose both SSH and an application. So I need an app, a node and app type token. And you'll notice here in terms of my Terraform, I have my provider. It's the gravitational.com teleport provider. I have a variable of the token itself. So that's something I'm going to set prior to invoking this configuration. I'm saying, well, what is the address? Again, that's my enterprise tenant. A bit of a Star Trek fan. That's why I chose that. And then I have my identity file path, which again is a credentials I've already issued from my auth server that's allowed to call to that. And then here's the actual configuration of the token. So I'm saying this is, I'm taking in the variable teleport token. So that's an input I'm giving. I'm giving it the roles of node and app. I could also give it Kubernetes and database, but I'd say, it's good to confine it to specifically what you're going to use because, per the security protocols Ben went over earlier. I'm also giving a label, so you can label these tokens as well, not just setting the specific roles, as well that I can give a description. So let's go ahead and let's take a look at the tokens we have right now. And I'd already logged in into my enterprise tenant. And this is all you can see your status of where you logged in, who you're logged in as, and your roles. Then I'm going to take a look at, well, what tokens are available. We can see I'd already made one there. So I'm going to go ahead and remove that token and create another one. If we list again, we have none. I'm going to set that variable, and I'm using UUID, which gives me a sufficient length token as opposed to just randomly typing or giving too short. Now, once I've given that, I can then apply, and it will confirm with me that I do want to add this token. I'm using that UUID value. It's going to credit. It tells me that it has applied the resource, and then we can take a look at the list of tokens, and that is now available with an expiration time. Now, in terms of retrieving that token, very similar to that client example you saw. This is a Go program that can call into. It's using an API token user credentials. It's calling into the proxy. In this case, it's going to retrieve tokens. It's going to actually print them out in a JSON format that I'm going to pass to another script. Part of it, it's also looking to see if this matches a particular node type, which either is a default, I think, of node or database. I look for a database by default, or if the person passed in a certain parameter, it will just look for those, and then it prints out in a nice JSON format. Now, in terms of the Jenkins machine we want to add on, this is the terminal. I'd already logged in prior to this, and we can take a look at. There is a Jenkins running. We can see it's exposed on 8081. This machine is actually restricted. The only port that's open is for myself, coming in from my remote terminal. So there's no even internal or external access. But I want to expose this Jenkins. There's no existing teleport running, so we want to install that. And this is a script I've configured to do that, where and this is all available, our installation process. I'm going to add the repository for teleport. I'm going to install it. I'm setting particular environment variables that are used to retrieve that token, how it retrieves it. And then because it's coming in a JSON format, I'm going to pass that to JQ so I can pull out specific token I want. I made a very simple teleport YAML. identifying the node name, using that auth token, the proxy, and then a particular node ID. Often it's good with your applications, not just using a generic like Grafana or Prometheus. It's a good idea to label them as well as uniquely identify them, and that'll be easier on your users, especially if there's a large number of items. I then move the YAML file and then start the service, because when you use our repository approach, it will automatically set up a service that you can run. All right, why don't we go ahead and run that? So it's going to pull down the latest version of Teleport, 626. Setting up, okay. And then we can always check the status of that. You see that is running, it's connected. And we go back and refresh. We now see that Jenkins servers with a tier dev and type build. I can go in as my username. Again, I can see the Docker status that's available. And I can also see the application that was rendered, that Jenkins 423. And now I'm in Jenkins. I'm using the subdomain of my tenant to access through it, which previously this application wasn't available publicly. So we've gone through a full range of creating a token with the API via Terraform. We've been able to retrieve it. We then use that token to make Teleport services available back to a Teleport Pro tenant. And now the user can directly interact with those services.
Oh, it was a great demo, Stephen. Thank you.
Sure.
Let me get my screen share back. Okay, and if anyone has any questions about the demo, I know a lot was covered there. Feel free to ask us or Stephen, is that demo is that code going to be available afterwards, just for people to?
I can definitely share it, and we can create links probably in our GitHub discussions is where I'll put that.
Awesome. Okay, so I think I didn't know you were going to do Jenkins. So Jenkins is a great example of another thing that comes, which is people often ask, what do I do for robot and CI/CD services? As far as those services communicating with your infrastructure and nodes. And, of late, we've seen many CI/CD services being sort of the weak points in people's infrastructure that have been sort of vulnerable to different attacks. And so you'd want to make sure that the tokens that you have on these services, aren't very long-lived tokens. So going from sort of the least secure to the most secure, these are our sort of recommendations. So you could just use a static join token, or you could create a long-lived token, one every year, and then have to renew it. But what would you recommend would be, using our API to create either, a nightly, weekly, monthly rotation of those keys. And with Teleport, you can see you can create as many tokens as you want and just let them expire, so you can have a little bit of overlap, and you'll always have a token that's available to work. And I've even seen one of our customers, they create a token per CI run as another way of sort of really shoring up your CI infrastructure. And this goes back to our question. We had a question around our Teleport Cube agent. And our Teleport Pro users have run into this issue too, that the way in which the Cube agent currently works is once the pod has joined, if the service was to restart or renew, you will lose that short-lived token, and so the pod won't be able to join. Our kind of hack is, to send a very long token, which isn't necessarily ideal. And our plan is to use Kubernetes native mutual TLS secret store to, keep that connection alive, and then also work with our TCOD auth rotate. If you're interested, just subscribe to this issue, 5585, and I think it's not going to be in Teleport 7, but I think soon it'll be available. And the more people that plus one it, the more likely it will sort of get in mainstream faster. Okay, lastly, TLS. This is probably just a quick sort of chapter, but for people starting, often what happens is once they set up Teleport, they ran into the connection is not private. The cert authority is sort of invalid. And everything should be sort of secure for Teleport. So in Teleport 6.0, we improved our Teleport configure to have Acme support. And this will obtain TLS certificates for you without having to install Let's Encrypt and getting them yourself. So this makes setup much easier. The one caveat is that the cluster name has to exactly match the top level domain name. So, tele.example.com has to be where Teleport will be running for this to work. As part of this sort of Acme TLS certificate, we will also obtain star.tele.example.com. And this is used for those applications. So if you saw in Stephen's case, he had, I think it was Jenkins 458.enterprise.teleport.sh. And so if you want application support, just to get this working, you need to set up a wildcard DNS entry, which is sort of a bit unique. You don't necessarily see it that often, but everything else will work. All this is outlined in our sort of configured Teleport and our application guide. And then another improvement we have a request for discussion number 35. This is going to be focusing on simplified node joining for AWS, and it will use the embedded identity document that's available with AWS instances. And instead of having to use SSM or distributed token, this is an example on a node, but in the Teleport auth and proxy, you'll just define which accounts will you accept nodes joining, and this can make your setup much easier. This is still in the design stage. It's currently going through a security review. So if you're interested, this is a great time to sort of dive into the discussion and give us more feedback. But expect this sort of later in the summer. So brings us to the end. Not often we have like a good recommended next steps, but it's probably a good time to just do a token audit. There's not necessarily any wrong way to be distributing tokens, but there's always ways in which you could probably improve the security posture. We're always here to help. If you're new to Teleport, recommend downloading it, getting started. Start with static tokens, try dynamic, and then go to the API and sort of see how it fits into your workflow. And you can check us out on GitHub. So last up, feel free to ask us any questions. I see we've answered the dynamic question. So is there any other questions from the audience? Feel free to type it in the chat. One thing often here, will it be recorded and shared? Yeah, we'll likely put it on YouTube later today. And then we'll have a full transcription probably in a week or so. All right, give you a couple more minutes to type your question, but it looks like no one has any more questions, which is probably a good sign. So if you have anything else, please just join us in the Slack room, or you can just email us. Thanks for joining today. Hopefully this was helpful. Also, if there's any topic, we have one for Dave. Is it possible to add a local user via a token? Yes. And to add a local user via a token, you use tcuddle users add, and then Teleport will generate a sort of token for you, which will be short-lived, and then that user can set up. For creating local users, depending upon how you define your cluster, they may be prompted with requesting either a QR code or a hardware token. It's kind of up to you how you configure Teleport. And any other questions? All right. Thanks everyone for joining today. Stephen, do you have any closing thoughts?
Please check out Teleport. There's a lot of good examples in the docs in terms of just getting started. It's very easy to set up your own environment quickly. If you have an RDS database, get that connected. We step you through that whole process. So we'd just love to hear about your interaction with it. Questions on these topics like tokens. And we're interested in making sure that it's clear why we take this approach and how to integrate it in your environment.